Okay, we're still on chapter 20. This is part 5. We're going to talk about force vibrations. Let me dismiss my image and uh, go on with the lecture. Force vibration, establishing vibrations in an object by a vibrating force. Example, the factory floor vibration caused by the running of heavy machinery. You can look up on YouTube if you can do one of two, or you can do both of them. You can look up synchronized metronomes, the little devices that go back and forth to keep time for musicians. They can set, 3, 4, maybe 5 metronomes on a table. Then they all, they start them up randomly, but within a short period of time, they'll all synchronize. It's the same with pendulum clocks that have a pendulum that are swinging. If they're mounted on a wall, you can start them up, and if they're all out of phase or just randomly swinging, within time they'll all swing. They'll all swing together. There'll be the vibrations go through the wall for the clocks. It goes through the table for the metronomes, and you get these sympathetic vibrations from the vibration of the other either metronomes or clocks. The natural frequencies, the frequency or a set of frequencies at which an object preferentially vibrates. It's determined by the elasticity of the object and the shape of the object. There's sometimes in an engine, as you vary the RPM, it might vibrate a little bit, and you probably hit a resonance of all the metal and that's in the car. It doesn't happen often, but I have experienced it. So there's natural frequencies. Well, when I did the little, even though you couldn't hear it, when I did the little straw experiment with my drinking cup, there was a resonance to the length of the tube. That has to do with the shape of the object. Okay, so resonance is a phenomenon in which the frequency of force or vibrations in an object matches the object's natural frequency. That's what I was talking about, the straw. There was a natural frequency that was selected simply from the length of the tube of the straw. Swinging in rhythm with the natural frequency of a swing. Tuning a radio station to the carrier frequency of a radio station. In the old time radios, I'm sure nowadays it's done digitally, but in the old time radios, you'd have a tank circuit, an adjustable capacitor, and inductor that you would tune to the particular frequency that the radio station is on. Troops marching in rhythm with the natural frequency of a grid. You can set up a vibration there in the textbook. I forget what the reference is, but there was soldiers marching, and their marches actually caused the bridge to collapse. If you look up on YouTube, and I'll probably add it to Canvas, the Tacoma Narrows Bridge, the Tacoma Narrows, the winds set up a resonance, and here you have you'll see a concrete bridge that is twisting like it's made of rubber, but it's from the resonance that the winds cause on the bridge, and it caused the bridge to collapse. I forget when it occurred. There are old black and white videos of the Tacoma Narrows Bridge collapsing. Let's see. Example: a child uses resonance by pumping in rhythm with the swing's natural frequency. Just swing your feet back and forth, and you can get up pretty high. And here's a demonstration. This is probably one you can look online. This is one I had done in the lab when I used to go to the lab at St. Philip's. Is you these resonance boxes are also used to show beats. You have a little piece of metal that you can slide up and down to change the frequency of one of these. But in this demonstration, you have them both together, and you just strike one of these tuning forks to where there's an open end on each of these boxes, and you face them open end to open end, and you strike this one. It'll cause this other one to vibrate, and I don't think I have that a demo of that. If I were to ever go back to the lab, I might want to do that, but I don't think I did it. Or I don't think I have a video, but you can look it up on YouTube. Look at sympathetic resonance with tuning forks or something like that. If I find one, I'll find one. I'll post it. And that's the end of part 5. Let's see.